Look closely at the surface of this fluid medium. These rhythmic, outward pulsing waves behave remarkably like organic life, breathing and reacting. This is Lux Eterna, a 2018 installation by Jaime Lobato, exhibited during the Naturficial Technologies Vivas retrospective at the Centro de Cultura Digital. This is the physical setup of the artwork. You are looking at a screen embedded inside a wooden pedestal, emitting specific light frequencies in a darkened gallery. Standing in front of this glowing display, you might assume you are watching a digital software program, lines of code executing on silicon processors. But there is no software here. The mechanism driving this display is raw fluid thermodynamics. The installation bypasses traditional digital architecture entirely. Instead, it uses a liquid chemical solution to perform active, real-time computations. Lobato presents Lux Eterna as a reaction diffusion computer, a sculptural system where thermodynamics, rather than the artist's hand, produce the final form. This setup collapses the idea that code must be immaterial. Computation is not just a human artifact, it is a latent property of physical chemistry. To understand the weight of this shift, we have to look at the baseline of modern computing, the von Neumann architecture. Since the mid-20th century, computers have strictly separated memory from processing. They rely entirely on binary logic, using electrical voltages to store immaterial symbolic representations. A classical processor routes data through a rigid hierarchy of descending logic trees. A fluid medium, however, operates as a decentralized, continuous flow of expanding, overlapping waves. Lobato abandons the rigid von Neumann model entirely, opting instead for this reaction diffusion chemical computer. In reaction diffusion computation, the fluid itself serves a dual purpose. It acts simultaneously as both the processor and the memory bank. Data in the system isn't encoded as abstract electrical states. It is physically encoded in the shifting concentration profiles of the chemical reagents. Moving the computational substrate from dry silicon to a viscous fluid pulls technological agency out of the virtual realm, anchoring computation directly in material reality. The generative display you see is powered by a specific chemical engine, the Belousov-Zhabotinsky, or BZ reaction. As the BZ reaction unfolds in a shallow liquid medium, it produces these signature expanding concentric rings and complex colliding spirals. This reaction is a nonlinear oscillator. It operates far from thermodynamic equilibrium, which means it requires a constant consumption of reagents to maintain its state. The system processes information through these continuous, highly visible waves of oxidation and reduction spreading across the substrate. The visual output on the gallery screen is a direct, real-time translation of those localized chemical concentration shifts. Those exact same chemical shifts are simultaneously translated into the binaural audio track that the gallery visitor hears. The resulting patterns record the literal sound and image of matter actively computing its own physical state. To understand how chemistry becomes functional computational architecture, we have to look at how a fluid environment can execute precise Boolean logic. This schematic shows a logical AND gate mapping onto the physical collision of propagating chemical waves inside a Y-shaped channel. The input condition relies on an oxidation wave traveling down these specific physical paths. During operation, the precise collision of two waves creates a newly structured chemical concentration pattern at the intersection. In the output phase, that resulting wave pattern acts as a data payload, passed down the fluid circuit's stem. Because the chemical medium is contiguous, this logic processing occurs in massive, decentralized parallel across the entire fluid simultaneously. Variables like physical gravity, rates of fluid evaporation, and shifts in ambient temperature actively alter the computation's trajectory. Weaponizing environmental volatility as a variable demonstrates that computation is an open, embodied system rather than a closed process in a sterile vacuum. But a fluid needs boundaries. The active medium is guided by a physical constraint, a solid polycarbonate bas-relief structure. This technical image shows the physical geometry of the white outline shapes housing the red fluid. These specific curves and narrow channels dictate the exact routes the chemical waves travel. Restricting flow makes this carved polycarbonate shape the hard-coded logic architecture for computation. In 1968, theorist Jack Burnham established the concept of systems aesthetics. Burnham argued that the relevance of contemporary art was shifting away from the production of static objects and toward the creation of dynamic, responsive systems. This directly challenged the historical definition of sculpture, which traditionally valued inert mass designed to retain a carved or cast form indefinitely. The polycarbonate artifact acts as the physical boundary condition required to host the artwork's internal processes. The true sculptural act is the localized, entropic flow of time occurring in the active tension between that physical container and the reacting chemical matter. Because the installation generates evolving audiovisuals, Lux Eterna is frequently categorized within contemporary digital arts as an act of live coding. This assumes the artist is actively writing instructions in real time during the exhibition to influence the final visual output. That is not happening here. Lobato's role is strictly limited to establishing the initial chemical state and carving the structural boundary conditions. After that, he steps away. This deliberate yielding of control is an embrace of autopoiesis, the innate, self-organizing agency of the chemical network determining its own path. Assigning this decentralized material agency to a fluid permanently removes the human from the center of the technological narrative, fully dissolving the boundary between the natural and the artificial. The endless, unpredictable generation of Lux Eterna stands in sharp contrast to the static, entropic end state of a classical marble bust. There is a strict biological parallel at work. The rhythmic, self-organizing chemical waves mathematically mirror the viewer's own metabolic cycles and circadian rhythms. Eventually, those dynamic, pulsing chemical waves drastically slow down, slowly fading into a completely static, uniform, lifeless color. This highlights the thermodynamic inevitability of the installation. The reaction will eventually consume all its available reagents and reach static equilibrium. The live execution of the artwork is, in reality, the real-time observation of its thermodynamic decay toward death. When equilibrium is finally reached, what remains is not the active process, but the informational scar left behind in the spatial-temporal framework. This redefines the ultimate purpose and legacy of the sculptural act.